All right, we're going on to topic 5.4, and this deals with factoring when you have a trinomial that is in standard form of the quadratic expression. And in a sense, the letter A is here, and A equals 1. In this case. So our first term of the trinomial is going to be x squared. So 1x squared. And that's what we see here in examples 7 and 8. Examples 1 through 6 are matching, and some of these are the words that you're going to be using, and we'll illustrate them as we go along. Now, the first thing, there is a sort of a strategy, a protocol for factoring these. And the first thing is that they're set up in standard form. That is this form here. So where A is 1, B is 11. That would be the coefficient of x. And C is the constant term. Now you might say, well, how did we get to this trinomial? And if you recall in previous sections, we FOILed, and that gave us, in a sense, we had two binomials that we FOILed that gave us this trinomial. So as we go to develop a strategy to factor this trinomial, the first thing we do is see if there's any common factor in each of these, and there isn't any. Then our second thing to do would be to put two sets of parentheses going back to our FOIL here. And if you recall, we had to multiply this by this to get our first term, which is the f in FOIL. And as we look at this, it's just going to be x and an x. Because if we multiply our first terms, we get x squared. And we don't write the 1. Now we're going to reverse this a little bit, because what I'm going to suggest is, how did we get that last term, the L in FOIL? Well, we multiplied this times this and got this term. But we also have to remember that we multiplied the outers and then the inners, added them up to get 11. So again, this is sort of the artisan, the artist in us, where we look at this and say, well, what are the factors of 18? The factors of 18 are 1 times 18, 2 times 9, 3 times 6. And as we go over these in our mind, when I put the 2 and the 9 down there, I realized if I added them together, they would add up to 11. So we're going to try a 9 and a 2 there. And we're going to look at our signs. They're all positive. And now if we FOIL this, let's do it together. First, x squared. Outers, 9x. Inners, 2x. Add them together. You get an 11x. That's what we want. And then multiply our last two, and we get 18. Yes, this is the factorization of this trinomial into its binomial factors. And it's an art form. It is a skill. And by practicing, you develop its techniques. And I see I didn't copy this one correctly. All right, that's better. You have to copy them down correctly. Okay, as you look at example 8, again, it's in standard form of the quadratic expression, descending powers of t. There's no common factor that I could factor out. So my next step is to put two sets of parentheses and then reverse the FOIL. So what do I put here in order to get a t squared in my first position? And if you said t, that's correct. Now again, we're thinking of our last that will add up to a negative 13. So factors of 40. 1 times 40, 2 times 20, 4 times 10. And notice this is a positive and this is a negative in the middle, so both of these, in order to give me a positive, would have to be negative. So all of these are really negative. But we can go like this. Then we go 5 times 8, and then once I get there, I realize 5 plus 8 is 13. So it looks like I have the factors. But this is the mental part of what you do, the artisan, the artist in you, where you look at something and you develop a strategy to get to an answer. And then now let's FOIL. T times t, t squared. Your outers, a negative 8t. Inners, a negative 5t. And mentally you do this and you add them together and you get a negative 13t. And then multiplying your last, a negative 5 times a negative 3 gives you a positive. And as we go through these, you're going to develop a strategy. For number 9, step 1, is it in standard form? Yes. Is there a common factor? Yes, there's an x that's common. So you have to factor that out first. Now it's in standard form with no common factor. And again, you have to include this x in your factorization. You then put two sets of parentheses, where in a sense we're going to undo the FOIL. So, in our first position, now notice here we have a negative, here we have a negative. In order for that to be true, one of these has to be positive and one needs to be negative. So we're looking now for factors of 12 that have a difference of 4. And again, I can go through 1 times 12, 2 times 6, And since I knew my middle term is negative, I knew the 6 had to go there, and the 2 would be positive. Because when I FOIL, I get x squared, a negative 6x, a positive 2x. That's going to give me a negative 4x for my middle term. And then for my last term, I'm going to get a negative 12. Remember, the x is part of the answer. This is your factorization. As we look at example 10, it's in standard form. Is there a common factor? And the answer is yes, there's a 5 here. So I factor out the 5. And this is going to be 14. Now, notice where up here we had a negative for the middle term. Here we have a positive for the middle term. And for our third term, that was negative, and so is this one. So again, the 5 is there. 2 sets of parentheses. Now we're looking for factors of 14 that have a difference of 5. And again, our n goes there. And then we know we're going to get a 7 and a 2. Because the difference between these numbers is 5. Now we notice that 5 needs to be positive. So we have 2 numbers to choose from in terms of our signs. One's going to be positive and one's going to be negative in order to give us that negative 14 when we multiply the 2 times 7. And since my 5 is positive, that's the bigger number, I'm going to put the 7 as positive and the 2 as negative. So once again, you check these by doing the FOIL, n times n, n squared. My outers, a positive 7n, my inners, a negative 2n, that when I add them together gives me my positive 5n. And then my last, for my FOIL, gives me a negative 14. Now notice, as we factor and practice the FOIL, it helps us review what we learned in previous sections. So the FOIL is a very important thing. All right, let's do 11. First, is it in standard form? And as we look at this, we see it's not in standard form. So we have to rearrange it in descending powers of a. So that's going to be a squared minus 15a plus 44. Is it now in standard form? Yes. Is there any common factor? No. So the next step is to put 2 sets of parentheses. And by the way, what I've just gone over, the steps to factor something, this is going to be our essay question for Chapter 5. So an A here, an A here, and we're looking for factors of 44 that add up to 15. Because since this is negative and this is positive, in order for that to happen, both of these signs must be negative. So we go through the factors of 44. 1 times 44? Nope, that doesn't add up to 15. 2 times 22? Nope. But how about 4 times 11? Yes, that adds up to a negative 15. And as you develop your skill, you're going to be foiling That gives us that. Negative 11a, negative 4a, adds up to a negative 15a. And then the product of our last gives me a positive 44. As we go on to number 12, and hopefully you're developing a pattern now. Step 1, is it in standard form of the quadratic expression? Yes. So step 2, put 2 sets of parentheses, and you're going to put a t there and a t there. Then as you look at this, you're saying, what are possible factors of 11? Well, since the number 11 is prime, it only has 2 factors, an 11 and a 1. There are no other factors for 11. Is there any way we can move those around in order to factor number 12? Well, we tried, and in fact, if I were to do this, I wouldn't even have put parentheses here, because I know there are no factors of 11 that add up to 8. So this is prime. And prime means that it's not factorable in these normal ways of doing it. Okay, number 13. Is it in standard form? Nope. So put it in standard form. X squared plus 15x plus 36. And again, sometimes when you look at these, right away you can tell if they're going to be prime. So as I looked at the 11, I could see there was no factors of 11 that would make it 8. But here, we don't know, so we try it. And it's in standard form now. There's no common factor. Put 2 sets of parentheses, an x there and an x there. So this is our pattern so far. Now you look at the 36 and you say, what are factors of 36 that could possibly add up to 15? Well, we could put them out here. 1 times 36, 2 times 18, 3 times 12, 4 times 9. Well, I didn't need that one because I have 3 times 12. 3 times 12 are my factors. And when they're all plus in your trinomial, these will always be plus. Check it by FOIL. And that checks. All right, now as we look at number 14, it's not in standard form. So let's do so. Negative n squared, negative n, and a positive 42. Now, when I see something like this, one of the first things that comes to mind is we don't like to have that first term as a negative. So what did we have in a previous lesson that would allow us to make this a positive? Well, one of the lessons we had was to take out a negative 1, and that reverses our signs. So this now becomes n squared plus n minus 42. So what we did is we took out a negative from each term, a negative 1, that reversed all these signs. So our negative 1 stays there, but then this factors nicely. An n and an n And then factors of 42 that have a difference of 1. Well, the common ones that jump into my mind are 6 and 7. And we want our middle term to be positive. So the larger number here needs to be positive, and the other one is negative. And that's our answer. Now, an alternative to this answer would be is if we multiply this first one by a negative, which would then give us negative n, negative 7, and then n minus 6. So this would be a satisfactory solution. I like this one myself. Works out very well. And our book does give both of those. I'm skipping number 15. I think we covered that enough, but I'll be sure to try to do every one that's a little different. So as we look at number 16, is it in standard form? Yes. Is there a common factor? Yes. In fact, you want to take out the largest common factor, which happens to be 12z. So this becomes z squared minus 2z minus 15. And again, if you started with, let's say, a 2 or a 6, you realize you could take out also a 4. You would still have something left in the parentheses. That wouldn't be completely factored. So there would have been something less until you take a 12z out. Then you end up with this. So 12z, 2 sets of parentheses, z and z. Then factors of 15 that have a difference of 2. Well, a 5 and a 3. And you want your middle term to be negative, so the larger is negative, and this one is positive. And you check by FOIL, and it checks out. Number 17 is a little different, because here you have powers of A descending, but then you have powers of B ascending. So this is in standard form. Is there any common factor you could take out of everything? And the answer is no. So next step, 2 sets of parentheses. Now, students are often at a loss in terms of strategy as to what to do. Again, put it in standard form. Take out any common factor, the greatest common factor. And then the next step is 2 sets of parentheses. Now notice you could set this up. You're going to put an A there, an A there. And then since you need that B squared, a B there, and a B there. So you're moving along with things that they're not really artistry. These are just standard things. But now you're looking for factors of 22 that have a difference of 9. So how about a 2 times 11? And you might say, how did I get that? Well, again, I've been doing this for a while, and in my mind, again, I don't know the answers right away. I have to do sort of what a student needs to do and think about it, and look at factorization of 22. Again, it's just 2 times 11 and 1 times 22. So there's not a lot of choices. But once I saw the 2 times 11 in my mind, I knew that difference was 9. That's how I got to it. And this has to be negative, the middle term, so my larger one will be negative, and this will be positive. Number 18, standard form, yes. Any common factor, yes. What is it? Something about the y's, yes. Y to the third, and then you're left with y squared minus 74y plus 73. Again, no common factors, so my y to the third times, and then two sets of parentheses. Remember, a is 1 here, so this is going to be a y and a y. And we want to get factors of 73 that add up to 74. Notice this is negative and this is positive, so both of these have to be negative, and it's just 73 times 1. So as we FOIL it, we get y squared. Our outers, a negative 73y. Our inners, a negative 1y, which adds up to a negative 74y. And then our last gives me a 73, positive. And again, you're going to have to practice this. Now, as we continue with the examples in our workbook, we're using factorization to solve quadratic equations now. This is no longer just an expression, because I've added an equal sign and we're saying it equals 0. And this goes to this topic, 0 and factoring. Now, in this expression here, which is an equation, we're saying a times b equals 0. This is a truism that either a or b needs to be 0 in order for this to equal 0. So 0 times anything is 0. So either the a is a 0 or both are zeros in order for that to be true. But in our work here, instead of just having it being a single term, we're saying it's going to be a binomial. So if this binomial has a result of a 0 in there, and this one has a result of a 0, then it will equal 0. This is the 0 property of factoring, where you solve an equation where you equal the factor to 0. And then we're going to take our factorization, equal each factorization to 0, and then solve this, and you'll see how it fits in. So we're now introducing a way in which factoring can solve quadratic equations. So, what do we do here? Well, we have to factor this. Remember, we're saying it equals 0. So our factoring is not too difficult. In fact, we had one just like this. Now, what's our next step? Well, we take this factor and equal it to 0. That's what I have set up here. And it would be interesting on your, or needed on your homework log, in your homework log, to put the word or, and then put this other factor. And you'd be developing a protocol, a strategy for solving equations by factoring. So what do we have here now? Well, all we have to do is transpose that. X equals 1. And here, x equals 9. And our solutions then for this equation is that x would equal 1 or x could equal 9. And let's just do one here. If x is a 1, 1 squared is 1. A negative 10 times 1 is a negative 10. And then plus 9. Does that equal 0? Well, there's your positive 10, there's your negative 10, that equals 0. And if you put the 9 in there, I'm not going to take the time now, but that would equal 0 as well. So in any equation in which there are two, the degree of the equation is 2, you're going to have 2 roots, which we said was a synonym for a solution. And here, our answer to this would be, we'd usually put it in a parenthesis, something like, or brackets. It would say, our answers are 1, 9. And that would be for number 19. And what we did is we had a quadratic equation. We factored the quadratic equation, equaled each of the factors to 0, solved and got, because it's a degree 2, 2 roots, 2 solutions, and we checked one of them, and the other one works too. And we're using the zero and factoring principle that I've illustrated here. Let's do this one. Factors of 35 that have a difference of 2 would be a 7 and a 5, is 35. We need a positive 2, so the larger factor will be positive. This will be negative. And if we FOIL this, it checks. And now our next step is to write it t minus 5 equals 0, or t plus 7 equals 0. And here we know t will be 5, and here t will be a negative 7. And again, let's check one here. The positive 5. Well, 5 squared is 25. 2 times 5 is 10. That adds up to a positive 35 and a negative 35, 0. So 5 is good. And negative 7 would work as well. And again, when you put this into your practice or quiz bees, that's your check. In example 21, here they're asking you to solve this particular equation by graphing. And again, we're not graphing, but I'd like to show you something about this. As we look at this equation, another way to think of it would have been f of x equals this x squared minus 3x minus 4. And this would be in function notation. And what did we say we could substitute for f of x? We said we could substitute the letter y. So we would have the equation in the sense that this equals y. And what are we saying y is when we have an equation written this way? Well, we're saying y is 0. So again, it's our old t-chart. And we see, where is y 0? Well, y is 0 at this spot and at this spot. So if our y coordinates are 0 there, what will our x be? Well, our x is a negative 1, And this other x is 1, 2, 3, 4, a positive 4. This is sometimes described as finding the zeros. I'm going to write that out here. Finding the zeros. And actually, this is what they're asking you, except this is the shortcut way of asking it. When y are zeros, what will our values of x be? Now, we showed one like this in one of our earlier programs, but we're going to now solve this by factoring. So here, x is going to equal -1, and here x equals 4. I shortened this a little bit to show you how it fits in with using a graphing calculator when this is in a functional form, when you are finding the zeros. Okay, we left number 22 out, which is similar to 21. But 23 shows now this quadratic expression in function notation. And actually what they're asking us to do here is to find the zeros. This is going to be a 0 here, which will stand for our y, and we're going to factor that. Remember, this is equal to 0. Take a moment to see if you can figure out the signs. Because the middle sign is negative, my larger one has to be negative, and this will be positive. So here, x will equal -3, x equals 8. So my answer set is -3, 8. Again, we could substitute a y here, or in this case, a 0. So we notice we can factor out a greatest common factor of x here. And we could put the 0 over there. This becomes x squared minus 13x plus 30. Now the x is important. 2 sets of parentheses. X, x. Now we're going to factor 30. And I can see 2 and a 15. And by the way, you could have put those either place. And the middle term is negative. And that is not correct. So I'm going to have to erase it and continue to work on that. And it just goes to show you that I'm working on these as you are. I had a 15 and a 2. Now if this were a negative, that would have worked. But this is a negative and that's a positive. So both of these signs need to be negative. Well, what other factors? Well, I had to go to the next one. A 10 and a 3. Now, that gives me my positive 30. And when I FOILed it, I realized before I didn't get it, but now that's correct. So keep in mind that when we started this is an equation to the 3rd degree. So I'm going to need 3 answers. So I equate each of these factors to 0. So one will be x equals 0. This one will be x equals 3. And this one will be x equals 10. So my answer set is 0, 3, 10. And I'm glad that you saw that when I tried this, it looked good in the beginning, but it didn't match up with what the signs were when I foiled it. So I had to guess and check, so to speak. That's coming up. All right, we skipped a few, but again, we're going to be sure to hit every one that might be a little different in type. So as we look at 27, here we have a squared equals 12a. You might say, how in the world would we do that? Well, again, we have to put it in standard form, which will be a squared minus 12a equals 0. And by the way, to change the quadratic standard form for the quadratic expression, we make it a quadratic equation just by equaling that expression to 0. And that's what we've done here. It's now in standard form of the quadratic equation. And we're going to use factorization to solve this. So again, is there a common factor? Yes, there's a common factor of a. So this becomes that. I just factored out the common factor of a. Now I can use this principle. So it'll be a equals 0 or a minus 12 equals 0. So this already is a solution, and this will become a equals 12. So again, this is an equation to the second degree, so I need 2 roots, and my answer for this would be a 0 and a 12. A little carried away there. And then as you get to more difficult things, you see something like this. Is it in standard form? No. And you want to try to keep your x squared positive. So I'm going to transpose the negative x squared to this side, where it now becomes positive. And I transpose the 50, changing its sign, and that equals 0. Now I could rewrite it that way, but this way is okay. This will be 0. 2 sets of parentheses. And I'm going to check this first. Yes. One's positive, one's negative. So this is a plus and that is a minus. So when you see something like this, you can almost pick out your answers. They're going to be opposite signs. Here x will be a positive 2, and this x will be a negative 25. It's what would make this factor a 0. If x is a positive 2, this becomes a 0. And we can use our 0 factor principle in solving equations here. Okay, that wraps this up. We'll move on to topic 4.5.